Hi, I am Rakesh Umdi, HOD of Mathematics Department, Jain Polytechnic, Belgavi. Today I'll be discussing a fifth chapter, that is complex number in Engineering Mathematics 1. In this chapter I'm going to cover introduction of the complex number, expressing in the form of a plus ib form, modulus and argument of a complex number, polar form of a complex number. Introduction. Meaning of imaginary number and its value. The concept of imaginary number and a complex number came out in the process of solving the equation x square plus 1 is equals to 0. That is x square plus 1 is equal to 0. Plus 1, if you shift this side, it will become minus 1. X square is equal to minus 1. X is equals to square root of minus 1. We don't have the fixed value for a particular value for square root of minus 1. So this we denote it as I, that is imaginary number. Euler was first to use the symbol for square root of minus 1, that is I is equals to root of minus 1. If I square I, then I'll get minus 1. This idea opened the field of the complex number. In other words, it extended the number system. Now we got a whole new part of the number system, that is a complex number. In this chapter we study the properties and applications of complex number. Now, definition of a complex number in the form of a plus ib. If a and b are real numbers, then z is equals to a plus ib is called as a complex number, where I is equals to square root of minus 1. For example, z is equals to 3 plus 2i, one complex number, or z is equals to 5 minus 7i. This is also a complex number. Now, the modulus and the conjugate of a complex number. Suppose, let's consider one complex number z is equals to a plus ib. The modulus of z is a non-negative real number denoted by mod z, and it is denoted by mod z is equals to square root of a square plus b square. A and b are real valued numbers. Conjugate of a complex number z is given by z bar is equals to a minus ib. If the complex number z is equals to a plus ib is there, its conjugate will be a minus ib. If it is a minus ib, then its conjugate z bar will be a plus ib. Amplitude or argument of a complex number. Now, how to find out the amplitude or the argument of a complex number? If a and b both are positive, then amplitude will be tan inverse b by a. If a is positive and b is negative, then amplitude will be minus tan inverse mod b by a. If a is negative, b is positive, then amplitude will be pi minus tan inverse b by a. If both are negative, then it will be minus of pi minus tan inverse mod of b by a. Now, we'll study the complex number, its properties, its applications using some examples. First example is evaluate I raised to minus 999. We have to simplify this. Given I raised to minus 999. If I bring it to the denominator, it will become 1 divided by I raised to 999. That is I raised to 999. Now 999 you have to divide it by 4. Why do we have to divide it by 4? Because I raised to 4 value is 1. First of all, you have to understand this. You have to remember this. I square is minus 1. I cube is minus I. I raised to 4 is 1. 1 divided by I is minus I. If I divide 999 by 4, then I'll get the remainder 3. Now this can be written as 1 divided by I raised to 4 raised to 249 into, the remainder will be separate, that is I raised to 3. We have to write it separate. I raised to 4 is 1, 1 raised to anything is always 1 only. I cube is minus I, here we have the value 1 upon 1 into minus I, that is minus 1 upon I. Minus 1 upon I is minus I, hence minus of minus I, it will be minus into minus plus I. Plus I is the simplified value of this I raised to minus 999. Here we have one more example. Evaluate I raised to 98 plus I raised to 72. Again we have to do the same thing. 98 we have to divide it by 4, as well as 72 we have to divide it by 4. 4 24s are 96 into the remainder I square we have to write separately, plus 4 18s are 72, the remainder will be 0, therefore I did not write any extra term here. I raised to 4 is 1, 1 raised to 24 into I square is minus 1, we have here I square value, plus I raised to 4 is plus 1, I raised to 4 is plus 1 raised to 18. 1 raised to 24 is 1 only. 1 into minus 1 is minus 1, plus 1 raised to 18 is 1. Minus 1 plus 1 will be 0. Now we'll move on to the next part, that is expressing in the form of a plus ib. Here in this we are going to study how to express a given equation in the form of a plus ib. Given complex number in the form of a plus ib. This is the standard form. Or how to find out the real and imaginary part of a complex number. Find the real and imaginary part of 2 minus 3i. It's very simple. They are given z is equals to 2 minus 3i. Now we know that standard equation of the complex number z is equals to a plus ib. A is 2, this is the real part, and ib is minus 3i, this is the imaginary part. Express the product 1 plus I into 1 plus 2i in the form of a plus ib. Second example it is, now given 1 plus I into 1 plus 2i they are given. Multiply these two binomials. 1 into 1 is 1, 1 into 2i is 2i, plus 1 in I into 1 is I, plus I into 2i is 2i square. 1 as it is, 2i plus 1i is 3i. Now 2 into I square value is what? Minus 1. 1 plus 3i, 2 into minus 1 is minus 2. 1 minus 2 is minus 1 plus 3i. Here this is real part and this is imaginary part. Find the real and imaginary part of 1 upon 3 plus 2i. Whenever if it is in this form, then in that case we have to rationalize the denominator. 1 upon 3 plus 2i into the rationalizing factor of this is, the conjugate of this is 3 minus 2i divided by 3 minus 2i. Multiply and we have to divide. 1 into 3 minus 2i is 3 minus 2i. 3 plus 2i, 3 minus 2i. It is in the form of a plus b, a minus b. That is a square minus b square. That is 3 square minus 2i square. 3 minus 2i divided by 3 square is 9, minus 2 square is 4, I square is minus 1. 3 minus 2i divided by 9, minus into minus plus 4. 3 minus 2i divided by 9 plus 4 is 13. 3 divided by 13 minus 2i divided by 13. This is the real part and this one is the imaginary part of the complex number. Moving on to the next part, that is modulus and amplitude of a complex number. How to find out the modulus and amplitude of a given complex number? We have here one example. Find the modulus and argument of the complex number z is equals to 1 plus root 3i. Given z is equals to 1 plus root 3i, we have to equate it to the standard form of the complex number, that is z is equals to a plus ib or b into I, no problem. Here a is 1 and b is root 3. Now modulus, as we know this formula, r is equals to square root of a square plus b square. This will be the modulus, mod of z. R is equal to square root of a square, 1 square plus b square, root 3 square. 1 square is 1, root 3 square is 3. 1 plus 3 is 4. Square root of 4 is 2. 2 is the modulus of this complex number. Now they also asked to find out argument. Argument as a and b both are positive. If both are positive, then the argument will be tan inverse b divided by a. If a is positive, then b is negative, then minus tan inverse mod b divided by a. If a is negative and b is positive, then that time it will be pi minus tan inverse b divided by mod a. If both are negative, in that case minus pi minus tan inverse mod b by a. Now at present here both are positive, hence I have to take theta is equals to tan inverse b divided by a. Theta represents argument, or else we can call this as amplitude. Theta is equals to tan inverse b is root 3 divided by a is 1. Root 3 divided by 1 is root 3. Tan inverse root 3 is what? 60 degree, or we can write in the radian form, that is pi divided by 3 is the argument or amplitude of a given complex number. One more example we have here. This is a little bit different. Express the complex number 1 plus I in the polar form. Now here they are given z is equals to 1 plus I. This is the complex number. We have to equate it to the standard form of the complex number, that is z is equals to a plus ib. Here a is 1, b is also, the coefficient of I is 1, therefore b is also 1. Now modulus, r is equal to square root of a square plus b square, r is equal to square root of a square 1 square plus b square 1 square. 1 square plus 1 square is root 2. The modulus of the complex number is r is equal to root 2. Now moving on to the argument, as a and b both are positive, here both are a and b both are positive, theta is equal to tan inverse b divided by a. Theta is equal to tan inverse b is 1, a is also 1. 1 divided by 1 is 1. Tan inverse 1 is what? 45 degree. That is pi by 4 in the radian form. Theta is what? Pi by 4. That is the argument or amplitude. Now we know that polar form of the complex number z is equals to r into cos theta plus I sin theta. Z is equals to r is root 2 cos theta is pi by 4 plus I sin theta is pi divided by 4. Therefore z is equal to root 2 into cos pi by 4 plus I sin pi by 4 is the polar form of the given complex number.